I'm a marine ecologist, and one of my specialties is looking at chemical fingerprints in the bones and shells of marine animals. And we do that as ecologists to find out where they come from, how they're moving around, and how the environment is changing around the animal and how that affects them. So I took those skills in ecology and a little bit of skills in geochemistry and translated it to the field of food provenance, which was the focus of my future fellowship, particularly seafood provenance. So if you go, that's just knowing where seafood comes from. Seafood, people might not know this, but seafood is actually the most traded food product in the world, exceeding even things like coffee, wheat and sugar. And that makes it particularly vulnerable to fraud. So the seafood that you buy from the shop might not actually be where it says it comes from. And then if there's practices like that, it can undermine their sort of brand and product value, like we saw with the honey crisis, when people found out that honey actually wasn't honey and it was affecting the local producers here. So I work particularly on the shells and bones of animals, because the chemicals, the trace elements and the isotopes, or many of them, are locked in within these structures in a very predictable and reliable way. So I did bring a prop. So this is an abalone shell. This was caught quite recently off the southeast coast of South Australia. And this is one of our samples. And abalone form highly valuable fisheries across southern Australia. So why we like these is the shells are made out of the calcium carbonate mineral. And like most seafood species, most animals or seafood have these calcium carbonate structures. I work a lot on octopus, and even octopus have calcium carbonate ear bones just behind their eyes, and we use those as well. So one nice thing about this particular mineral is that certain isotopes and trace elements lock into that calcium carbonate in a predictable way. So a key theory in my fellowship that I want to test is whether you're an abalone or an octopus or a sea urchin living in the same body of water, even you're such hugely different animals on the tree of life, that you, in theory, have the same fingerprint in your shell or your bone. So if we can find those universal markers, that's what I like to call them, then we can use those tools to track where animals come from, can have applications for provenance if they're commercially harvested, and also we can find out a lot about their biology and ecology. So it's just a surface of where we predict high and low values of isotopes, and we can validate that with the animal. And we can do that with oxygen isotopes because they're quite well studied in terms we know they relate to salinity, water temperature and latitude in quite a predictable way. Our preliminary results are showing that oxygen isotopes are great, but they're quite, the spatial resolution is quite coarse. So the focus of my fellowship was particularly Southeast Asia and Australia, because 70% of our seafood we actually eat in Australia is Asian, which might surprise a lot of people. And that's where the huge amount of trade. And then we also sell a lot of our high value fisheries, like rock lobster and abalone and those sorts of things, to the Asian markets. So those two scales are very easy because you've got tropical waters and more cold climate waters. But what we're looking at is a bit more on a national scale, so samples between states and what resolution. And we are getting differences with oxygen isotopes, but it has its limitations. So now we're looking in terms of if you've got all these animals collected from the same latitude, for instance. So now we're also looking at potentially other. That's one of the first main ones, and it's relatively easy to analyse. And we're looking at some other, like some rare earth elements and a particular type of some trace elements where we have a lot of knowledge about how they're incorporated. And then the idea is to build multiple isoscapes of the different isotopes to get a high resolution, both on latitude and longitude. You know, I grew up in the bush, so I like nature, so I decided to study ecology, but one of my other loves was writing. I wanted to be a novelist, and you know, I was choosing one or the other. So when I went to science, I felt probably more comfortable with words than I did numbers, and I was probably a bit different in that way, because people, you know, people don't think you have to be so good at English than you have to be good at maths, getting into having a career in science. And it's, you know, it's less of the creative disciplines and the more quantitative disciplines. But I found that as scientists, the reality is we do spend 80% or so of our lives writing. And the more senior you get, the more you write as well. And it's just, you know, it's not taught as much as a valuable skill as it is quantitative skills, even though they're absolutely critical. So and as I was writing more and more, I was getting frustrated with the style of scientific writing. And it was just, if you wrote in a slightly different way, particularly if you sent a paper out to review, you just got the comments back that it's inappropriate. And I'm like, well, why is it inappropriate? Because I've written a sentence that's much more approachable and easier for the brain to comprehend and understand. And there's this sort of conflation that if you write in an approachable and slightly different way, that it's not objective. As scientists, we want to be objective and accurate. And that my colleague who was working with Sean Connell, we were both like, well, do you really need to be, can you write in an approachable way and not compromise your objectivity? So that's when I went on this sort of, what seemed like a rabbit hole at the time. And, but it was an enjoyable one, and it's had much bigger impact and sort of influence and momentum that I thought it would ever have, writing these papers and feeling that there's so many other scientists and students feeling the same way. So I've done lots of training students and staff how to write in a more approachable way, how we train to write in a very certain way, and it's very hard to go outside that box, particularly when we do. Often we get, you know, no, that's not correct. And I'd have students come up to me and they'd say, I'd never thought I was meant for a career in science, because one, I'd read the papers that I'm trying to learn to read. I find them tough going. I can't understand them. It's not me. I feel like I'm more of a creative person, and maybe I don't want to do this. And I was sort of like, that's a great tragedy, because we need all these different diverse thinkers in science, and it's actually a very creative profession. And I was thought the way we're training people to write needs to be updated, and it needs to evolve with the times. Long are the days where we think we just write a paper and it's just read by 5 people in your sub discipline. You know, it's all about, you know, telling your science to the community, people in other sectors, government, corporate sector, and also much more interdisciplinary research. I mean, often you're scared off as a scientist if you read a paper in a different field and you can't get past the title, and you're busy and you're stressed and you put it down for another day because you can't get past the title. Because one, it might be full of 10 acronyms and you don't even know what the acronyms are. But if that paper was, even people think papers are just for scientists, but a lot of the work I'm talking about is papers are even hard to read for scientists as well. Science communication is important, and the work that you do in that field is important, and it being part of the program, you know, they encourage you more and more to get out there and be visible, and part of that is to be a visible role model, to get like a critical mass of women in the media, as we know that in my field, in biological sciences, there's plenty of women in the when they're coming through as students and early career researchers, but more or less disappear completely after that. And so it's about building that mass and those visible faces, those confident faces, and just being part of that movement. Sounds a bit cliche. I want to find another term. But you know that there's, you know, it's got backing from the institutions. It's sort of coming top down as well, that you've sort of got that momentum, both of communication, which I'm very passionate about, but also getting more women out there in the limelight. So on one hand, we're doing training, more training in media, and it's also about building networks with other women, learning what they're about. And yeah, it's sort of, and you sort of feel this confidence in the air, and things will change. You know, you've been in, you know, I've seen when I was a student, you know, most of my class were women, and all my lecturers were male men, and then even now when I was lecturing, it was still the same, you know, all the lecturers were men. You were like always the only, if you're in some sort of research leaders meeting, you're usually the only one in the room, or two or three. And so you do feel that frustration from time to time, but being part of this knows that there is things changing in a positive way, because that diversity, as you said, bringing in people who think in different ways in science, is because we're solving some pretty big problems. That's when we're going to see some bigger outputs from science. The key thing, it gives you independence, so you can build your own research and lead your own group. But what that does, it means you now have the capacity to support the next generation, because you have the stability. You've gone from surviving like month by month to having the stability and the support, and then, you know, the name of the fellowship, which helps, that then enables you to work and support the next generation. And I found almost that more satisfying than doing the research itself, is now I have that opportunity to do that. And most of the people I work with are women and early career women, so that's something that I really enjoy. Without the fellowship, it just wouldn't have been possible.